This is the second section in chapter 4, and these are laws of exponents. Similar to the first section, I think that probably much, if not all of this is review for you all. But again, this is one of these so critical operations in Algebra 2 that if you have trouble with this, it's really going to show up long term for you. So let's really work hard on this chapter in terms of laws of exponents. Now, the laws of exponents are listed for you in the box on page 171. But let me take a different approach in this, and I'm going to kind of paraphrase what is going on here. Basically, oh, that's way too big here. Let me go down a little bit. If we have any monomial here or an expression, I'm trying to erase this here. If we have any expression here with a variable, so we have a here, a, and a has an exponent, and it's always understood that the exponent is 1 if it's not listed, and we want to multiply by a to the third. So the question always arises, how do we deal with exponents? Well, the law says that we add these. Well, how can you remember that? And here is what I always do if I get confused, and I would encourage you to do. Figure out one way to test yourself. And you can always, in any situation, whether it's an exam, a quiz, or SATs, or further courses, you can, if you get stressed, you can go back and go, I can figure this out. So here's how I often think, well, here is a times a to the third, but a to the third really means a times itself 3 times. Now, that makes it a little easier. This is a to the 1 times a to the 1 times a to the 1 times a to the 1. How many of those do we have? We have 4. Now, that is the same as if we said a to the 1 times a to the third is equal to a to the 1 plus 3, which is equal to a to the 4th, which is exactly what this law is as it's stated on page 171. It says a to the m times a to the n is equal to a to the m plus n. So that's the first law here. Let me get a clean board and go over the next ones with you. Now, here are the second and third laws of exponents. So I'm going to start on this a little bit differently and present these to you. But I also like to be able to introduce these in the very same way and ask yourself what exactly is going on. So if you had just simply x raised to the third on the outside of a parentheses, this is equal to whatever is inside here times itself, the number of times that the exponent says. So this is x to the third. This is x times x times x, which from the first law of exponents, you know, is x to the third. Now, what if this was inside x to the second, all to the third? So the question is always, do I add these or do I multiply them? And here's the way to figure this out. The same reasoning applies as up here. What we're saying is whatever is inside this parentheses times itself 3 times. So we have x to the second times x to the second times x to the second, and that means we add them all up. Now 2 plus 2 plus 2 is x to the 6th. The only way that we can get that is not by adding these, because if we added 2 and 3, we would get 5. But now we have proven, beyond any doubt, that the answer here, correct answer, is x to the 6th, which means when we raise something, we multiply the exponents. That is this law. And it's connected to the third one in that, as I just said, I use this law to prove this. So if we have now 2 here, and we have x, let's say, to the second times z to the fourth, this is equal to, and again, all squared here, let's say. So we have x squared times times z to the fourth times z to the fourth. So we know now that we can add these. So this is x to the fourth, which is the same as multiplying these two. And I probably should have used a different one. And this is z to the fourth times z to the fourth, add. So this is z to the 8th, which is 2 times 4 and not 6. So this is x to the fourth. Sorry, that doesn't look like an 8, and it should. This is z to the fourth. X to the fourth, z to the 8th. We are multiplying individual exponents here. Now, I'm going to clean the screen, and then we're going to do a couple of problems from the written exercises. Let's start off with 2 examples on page 173, number 3 and number 4. So I want to point out an important principle here. So as we've shown in the laws of exponents, we have a parentheses here, and a problem with the parentheses here and here, and we have an outside exponent here outside the parentheses. So the question is, what do we do with that? And it's always a possibility of being confused. Do I add or do I multiply? The answer is you multiply. But how can you remember? Well, what this says is that whatever is inside this parentheses, I'm going to multiply it times itself 3 times. So I have negative t to the fourth times negative t to the fourth times negative t to the fourth. Now there's a reason that I have selected these 2 problems, because the question can become, is my final answer positive or negative? And what is the exponent? So let's look down at this one as well. And this is, I'm going to take whatever is inside here, which is negative t to the third, 4 times, negative t to the third, that's a multiply, times, these are all negative, negative t to the third. So listen, 1, 2, 3 negatives up here, negative times a negative is a positive, times a negative is a negative t, and add exponents. 4 plus 4 is 8, plus 4 is 12. How would I get that? I get that by multiplying these exponents. So the answer is negative t to the 12th. Down here, I have a negative, negative times a negative is a positive, times a negative is a negative, times a negative is a positive. So this is going to be a positive t. Now, 3 plus 3 is 6, plus 3 is 9, plus 3 is 12. So a couple of things to point out here, and I'm often reluctant to point this out because I don't want you to confuse it. This sign here and this sign here have nothing to do with the exponent. In other words, we don't get a negative 12 here or anything like that. It is the coefficient in the front of the term, here, here, and here. If it's an odd number, then you're going to end up with a negative. If it's an even number, you're going to end up with a positive. Let's look at one that's a little more complex. But again, these are polynomials with exponents, and of course all the same rules apply. However, there is one rule, so to speak, is that we do this exponent first. We do this guy over here first, and we apply those rules, if you will, to here. Now, this looks more complicated because rather than being just an s to the second, it's x to the 2k, and not only is it to the s to the 2k, but it's 2k minus 1. don't be concerned with this. We will be utilizing, and you will be utilizing in your future mathematics courses, lots of different exponents. So let's get used to this. The same rules apply. The same rules apply, except that we still have s to the third times whatever is in here, which is s to the 2k minus 1 times s to the 2k minus 1 times s to the 2k minus 1. Correct? Now, if we wanted to do this, and this is longer, add all of these together, and we would get s to the third, obviously, still. Now, if you add all these together, or if you distribute here, it's going to come out to the same thing. This is s to the 6k minus, add all these up, minus 3. That's the entire exponent. Now, what do we do with this? This is s to the third times whatever is in here. When we multiply this, we add the exponents. So this is the same as, this is s to the third times s to the 6k minus 3, which is s, and add exponents. 3 plus 6k plus 3, which is equal to, excuse me, this is minus 3. That's why this is minus 3 from here. I'm sorry. So the 3's are going to cancel here, and we are left with x to the 6k, which is what the answer is. So listen, do your diligent homework here on page 163. You're going to see a lot of this stuff in SATs, and shoot me an email if you have a particular one that you would like me to do in video. Hope this helps.